Welcome everybody. Orhun will be doing the next presentation. Please give him an applause and welcome him.
Welcome everyone. This is working, I guess. Okay, we are live. Welcome to my talk. I hope you like rats and terminals and a bit of retro computing, because there will be a lot of that in this talk. And we will go through a bit of history, and not history of rats, don't worry, but terminals and maybe rats too. Anyways, here's me, Orhun Parmaksız, and I love open source. I've been writing Rust for some time now, and I made these projects right now you see on the slide. And I'm a big advocate for terminal and overall doing things in the terminal, so these projects are mostly command line tools. And I've been leading a project called Ratatui, which you might be familiar with or not. We'll talk about it today anyway, so yeah. Lastly, I package things for Arch, by the way. So yeah, today I will be narrating a story. Because this talk is titled Renaissance, and we need to go through a bit of history to understand some things. After all, Renaissance means rebirth or revival of something, or like renewed interest in something. So yeah, let's just begin. So our story begins in 1978. Once upon a time, there was a terminal, VT100. Earliest of its generation, it's a prominent example of a video terminal. It actually changed the course of history. But before that, you might be asking, what is going on in this tiny screen, and what's that? Well, VT100 was one of the first terminals which has like a screen and like a video support. So if you look at its screen, you would see something like this. And I mean, it looks like a typical terminal that we use these days, like, you know, black background and white text, and there's some help menu there and so on. But it introduced many concepts which influenced the modern computing interfaces that we use today. And I'd like to say, and I want you to imagine, with this terminal/computer, you could control the lights, status lights on the keyboard. I mean, it was just, you know, groundbreaking stuff, but it was not the only thing that it did. It was also one of the first terminals which supported ANSI escape codes. I dig deep down in Wikipedia to find this manual, and here I search for ANSI, and you can see that it says something like it supports ANSI/VT52 modes. So yeah, it's one of the first terminals basically. So, but what does that mean? Like, what is ANSI and so on? Well, in the 70s and 80s, there were a lot of hardware and software manufacturers, and they all had their own way of doing things. So there were so many standards. And ANSI introduced several standards which became international, and it kind of like harmonized many things. So yeah, VT100 was one of the first terminals that supported these standards. And ANSI escape codes are basically some codes that we use to control the terminal and change some things, basically. So yeah, in short, VT100 supported these codes to control many things in terminal, like the cursor and the colors and other tasks. The best way to show you this is to show you this little video. Well, this is not ancient Egyptian alien technology. This was possible in the 80s. And it was all thanks to ANSI escape codes. And you can see pretty much some animations and some stuff like that. Well, if you think that's something that somebody made in their basement just for fun, it's actually not. There's a whole page of like art and animations for VT100. We have like stuff like Bambi, and if that's not enough, we have Bambi versus Godzilla. I don't know what's going on in that one. But yeah, and then if that's not enough, we have Bambi versus Godzilla from Dave Brett. Some guy didn't like the first version, so I guess he made his own. Cool. And there's Barney being crushed, but I don't have an idea about that. So yeah. We have like a lot of animations there, not just 3. We have around like 93, and yeah, the one that I showed you was Twilight.vt, not this one, but this one, Twilight Zone. So when you open the file with a text editor, you will see stuff like this, and these are, yes, you guessed it right, NC escape codes. So yeah, I want to break them down and show you what these like codes mean, basically. So if we take the line 2 from this file, and if we take a look at it, it does not really make sense at first, but we need to split it by some parts. And if we start with this 3 or 4 characters, it actually means, if you like send this to a terminal, it means that it will signal the beginning of an NC escape sequence. If you move on, you will have this bracket, which is called control sequence introducer. It's actually one of the more common NC sequences. So with these 5 characters, we basically start some command in the terminal. And if we go on, this 38 here means that set the foreground color. And then we have 2, which indicates that this color will be in RGB format. And this is actually the color codes in RGB. And the M at the beginning means that interpret these previous codes in a certain way. So if you don't put that M there, it means that do not like interpret that as RGB, but something else. So we need to put that there. And again, we have another sequence there towards the end. And 0M simply means reset everything. If you put this in a simple Rust program, it looks like this. So when you print something, like if you like put these codes like printed on your terminal, it will basically like change the color and then reset it. You can put anything between those codes, and it will be in this bluish color. And you might be asking, why do we have to reset it? Well, it's because terminal actually holds a state, so we need to reset it back to its original state. If you don't, the remaining of your session will be in this blue color, which is not something that we want. So yeah, those are NC escape codes, simply. Let's move on to the year 1990 and forward. Time has passed. Everyone was happy back then, probably. And 90s were the years of TurboVision. And I'd like to ask how many of you are familiar with this type of interfaces? Can I show hands? Wow, there are a lot of TUI OGs are here, okay. All right, so TurboVision is one of the earliest examples of a TUI library. It's actually a framework that was used to use with like Borland Pascal, Turbo Pascal, and like Borland C++'s IDEs. And it was quite influential, and it actually gave rise to a number of other ports and reimplementations. And with TurboVision, you could build this blue-looking, horrible colored Smurf themed like TUIs back then, and they were kind of awesome, actually. So yeah, as I said, TurboVision was used mostly for IDEs, and this is Borland Turbo C++. And this is especially beautiful because it has syntax highlighting. It has like all the cool TUI elements in it. It has like these menus and like these key bindings at the bottom and so on. So yeah, but not just Borland used Borland TurboVision. It's kind of obscure, but IDA Pro also used TurboVision back in the day in its prime time. And here you can see a slide that says, IDA's version, which was released in 1994, used TurboVision for its TUI. And for some context, IDA Pro is a widely known disassembler, and you can like run it on your machine to see some assembly, which was generated from machine executable code. And you can see that the year is 1991 here, and it's absolutely impressive. And later on, this TUI got ported to other systems such as Windows and Linux console and so on. And it will be a little bit of time jump, but I should mention this because it's very interesting. At one point, it was even running on iPhone, which is, I think, crazy. So yeah, anyways, going back. Also, there we have like a influential early implementation of Orthodox file manager called DOS Navigator, and it has a distinct look of this Turbo Vision views and like these like key bindings and so on. So yeah, and the color scheme is kind of better. I mean, not gonna lie, at least not blue this time. Moving on to another example, and I must say you're lucky if you've seen this interface before, because this is from the early days of World Wide Web. And at that time, internet software was immature. There weren't too many good stuff that you could do. And there was some FTP telnet programs which were glitchy, hard to configure, and all TTY oriented. So the University of Minnesota came up with this Minnesota Internet Users Essential tool. And what they did was they aim to make this thing runnable on a PC with at least 400 kilobytes of RAM, and it has a TUI design with Turbo Vision. It had features like email, FTP, even a web browser. Of course, no JavaScript. Thank God. Anyways, this was simply ahead of its time. That's what I'm saying here. So let's wrap up some things. We have an idea of what a TUI is. So a TUI is an interface made using text characters. So we have some special Unicode characters to draw like various things. And there's a sample diagram here, which was drawn here, with using these drawing characters. And they are connected horizontally or vertically, as you can see here. And we need to use like adjacent characters to properly align them and so on. So yeah, these standard box drawing characters are actually mentioned in this wiki, and there's like a whole page about them. You can go and check that out. And in there it mentions stuff like block characters or shade characters and thermal graphic characters. And one example of that is when you look at the earliest examples of TUIs, when you have this pop-up, you have the shadow behind the pop-up, and those are called drop shadows. So some characters here, probably not here, but they are used to like portray these shadow effects as well. And a TUI is designed to run in a terminal and a console because that was the standard before. And because of that, they are very efficient and lightweight. You don't need to rely on heavy stuff running, and you just rely on simple text characters basically instead of these graphical elements, which really reduces resource consumption. Okay, a couple of years passed, and in the year is 1993, and world of computing met something called Ncurses. I'm sure many of you are familiar with it at this point, but to put it briefly, Ncurses is a C library for creating TUIs, and it is widely used for many things, including the menu config of the Linux kernel. If you have built your own kernel before, you've probably seen this, and it allows you to configure the build settings and so on. Without this, you probably have to go through some configuration files and do some other things, but this thing really is very convenient. So Ncurses was used here, as well as some file managers. And this is Midnight Commander, one of the popular Orthodox file managers from back in the day. But most of the time, Ncurses was not really enough. So people came up with CDK because it was like pretty difficult to do some complex TUI stuff in plain Ncurses. CDK provided some additional widgets such as calendar, dialog, list, and graph. This is a Rust talk. I don't know why I'm showing you C code. Anyways. Just to name a few TUIs from this Ncurses era, we have Vim, Nano, and yeah, Windows 95 came, and GUIs started to become more popular after this point. And I'd like to show you something which is a picture that I took yesterday. My friend David here was kind enough to invite me to Hexco Hackerspace near Koblenz, I think. And there they had like this custom-made laser printer writer thingy, which has no documentation, nothing at all, no Wikipedia. Some guy or some company just built this. And something that really piqued my interest here is that it has this Windows XP running there, and you could like see this like very nostalgic the UI in that, and the year is 1997 or something, and it has like a lot of UI elements too. Like it has some paint thingy, and there's like menus and so on. So it was pretty interesting. So this were in 90s, and if we come to the 2000s, things started to change a bit. Does anyone know what this is? Well, it's not very hard to guess, I guess. It's Mozilla Phoenix 0.1, the first version of Firefox. And 2000s were the years of GUI apps, so they started to become more popular. Some other examples are Reaper, lightweight music software in 2006, and this was followed by GIMP, Blender, and so on. I'm not sure about the years of those, but GUIs were just more popular. And at the same time, TUIs were still high in use because power users usually preferred TUIs. HTOP, system monitoring tool, one of the OGs actually came out in those years. So there was some kind of balance between TUIs and GUIs. But then, 2010s, the bloat begins. The best way to describe bloat is actually memes. Linux users, when they update, and now their distro uses 28 more RAM than it used to. Pain. Systemd is bloat, Kitty is bloat, GNOME is bloat, blah, blah, blah. You will use minimal hardware Gen 2 with OpenRC, BusyBox with tile management. Yeah, you know where this is going, right? Me tries to install a snap package, the 840 gigabyte of remaining space on my disk, adios. Yeah, it happens. But let's have a more better description. So let's define it. First of all, it's an interesting concept, and it has some issues. And we face usually a higher complexity and excessive features in bloated applications. So if you overload your application with too many features that most users don't need, please stop. You're adding bloat. They have like complex interfaces. So if you're like creating an intricate, cluttered interface with, if you're making your application harder to navigate, please stop again. And this is actually one of the important problems that we are trying to solve with the TUI approach. And lastly, we all know that GUI apps or bloated GUI apps have performance issues. I mean, come on, it's not something new that we're running a lot of processes in the background, and this leads to a lot of resource usage. At the end of the day, bloated applications complicate the user interface, user experience, makes them very poor, leads to a steeper learning curve for new users, and frustration. So bloat means poor user experience and profound sadness. So don't make the rats cry. Let's take a look at one of the bloat examples. Sorry for the bad quality, but this is Spotify from 2009. And I want to ask here, do we really need all of these text and arrows to explain a simple music player? I mean, it looks very crowded and very hard to understand. But this is still not so bad, compared to what I'm about to show you here. Spotify from 2015. Well, you might be asking, this looks more modern, easier to use. What's the issue with it? Well, the devil is in the depths, because in this case, it's the underlying framework. Why do you think Spotify decided to rewrite their desktop app and update the design and features all of a sudden in 2015? Any guesses? Exactly. There was a new sheriff in town, Electron, and the premise is build cross-platform desktop apps with JavaScript, HTML, and CSS. And from the convenience of use perspective, Electron is great because it's cross-platform. You just write your functionality once, and the framework handles everything, and it's great. That's why a lot of the GUI apps or the desktop apps that we use today use Electron, Discord, VS Code, Obsidian, Slack. I hope you don't use it, but yeah. So, what's the issue with it? Like, what's the issue with Electron? Well, Electron bundles Chromium, which means that it essentially creates a full web browser for each app, which leads to many issues. So Electron apps become bloated because of this reason, because you basically bundle Chrome into that, and you won't get an Electron app smaller than 100 megabytes because of that reason, which is pretty bad. And second, they are not performant. It's highly correlated with the first point, but running a resource-hungry web browser for each GUI application on your computer is not exactly what your laptop batteries sign up for. So once again, we have poor user experience and profound sadness. And yeah, they always has been a website. Sorry. Now here's the latest interface of Spotify, and that's my album, by the way. You can check it out. And the interface still, to me, feels very crowded and slow. But the question is actually, why do we do this? Why do we keep making UIs more bloated instead of making them simple and fast? And French writer Antonio de Saint-Exupéry explained this very well. He says that perfection isn't achieved when there's nothing left to add, but when there is nothing left to take away. So, in other words, we need to acknowledge that less is more to achieve perfection, in his view. And I think this applies to many things in life, as well as user interfaces. So, in the midst of these UI developments, Electron, bloat, and everything, some people kept working on new TUIs because they potentially saw the value in them, and it was pretty fast. So, yeah, remember Midnight Commander? Here's a similar concept. Ranger is a Vim-inspired file manager written in Python, and it's just, being used by developers. It was running pretty fast, pretty efficient. So that leads us to the question: GUIs or TUIs? Let's take a look at their advantages or disadvantages to get an idea. TUIs, first of all, they consume fewer system resources. They rely on shortcuts or command inputs. So if you're already using Vim, you will be very comfortable using a TUI. And they operate on systems with limited graphical capabilities. So if you have SSH server and you want to, play Doom in that, you can just do that too. They can be accessed and navigate over a network connection, like I said. And GUIs, on the other hand, they have a very intuitive interface for new or casual users. They enhance user interaction with drag and drop features. And in a GUI, there's a more immediate or visual representation of the changes. So if you click a button, you click the button. That's what you see is what you get, basically. So yeah. Disadvantages are TUIs might be a bit harder to learn. They sometimes have limited visual appeal. That's the problem that we are trying to solve with Ratatui, actually. I will mention it. They are less intuitive. They have basic interaction features most of the time. GUIs, on the other hand, they require more system resources like CPU and memory, because Electron. Applications are generally larger and require more storage because Electron. They have low performance, Electron, and they are hella slow for power users and people who prefer keyboard shortcuts. So it's time. Let's talk about the renaissance of TUIs. I remember it very clearly to this day. A couple of years ago, I was browsing GitHub and I came across this repository, Spotify TUI. Maybe you might already know it. It's written in Rust and looks like this. And I was blown away by this. I mean, not because I use Spotify or anything, but possibility of making this happen in the terminal and browsing playlists and playing music was just very interesting to me. It's not something new. I mean, there are a lot of other TUI music players, but writing this in Rust was pretty interesting. So I started looking around a bit, and I found this repository, TUIRS. It's a TUI library for Rust, and this is now archived, but I'll explain why. But back then it was still developed and used by many Rust developers. They were just making hobby projects. So I did the most obvious thing. Yes, ladies and gentlemen, I started a new side project with the hope that I would finish it. And this was literally my first Rust project. I never touched Rust before in my life at this point. So it was kind of difficult, but I cooked. So the result was came on, a TUI for monitoring the Linux kernel and managing the modules. And I shared this on Reddit and Rust forums and other socials, and people pretty much liked it. And after this point, I felt like I was onto something with these TUIs and, of course, with Rust. So I kept going. Some years passed, and the author of the TUIs library, Florian, created this discussion on GitHub, and he raised some points and proposed some changes because he had some limited time to work on this library, and he was seeking new maintainers, and he was planning to do some community building as well. So he suggested that there should be like an organization for this project, and there should be some other social channels such as Discord and Matrix and so on. So he was very aware of the challenges and also the appeal of this library. That's why he had these concerns. And some people were interested. And I was actually invited to the discussion by Sayan, which is one of the earliest maintainers of Ratatui. And we needed to act quick at this point because the author just created this discussion and just disappeared. And we were like, what should we do? Because people started to fork the project, start their own projects. And we wanted to create a central place for discussion and development rather than everyone having their own fork. And there was a peak of attention to this crate at the time. So yeah, here's my first contributions to the discussion, just this comment. And I felt like I was changing the world actually. Yeah. Anyways. We were planning this fork, and we were just discussing in the issue. And the author actually came back and said that he is fine with the fork, and he also like proposed a plan for transferring the ownership. And he disappeared again, sadly. And after some time, we just created the fork, created a Discord, and we named it TUIs Revival. Now looking back at it, I wish we used the word Renaissance there, but anyways, we knew. And the rest is history. Here's the timeline. During these times, we frequently talked on Discord, planned our next big move, and how to proceed with some things. And someone came up with the brilliant name Ratatui for this library, and we were like, I mean, of course, no one could say no. We just went ahead with it. Someone designed the logo, which you can see on my T-shirt right now. I have stickers too, if you want after the talk. So there are blog posts detailing the entire history of this project, and I was also like featured on Russian Station podcast if you want to learn more about this. But long story short, we became the official successor of TUIs after the author archived TUIs repository and added a note to its README saying that Ratatui is the successor. So this is where we're at right now. And hopefully Ratatui will be the feature of the terminal, and we are really working toward that. We meaning not just the maintainers or developers of the library, but also the app makers, which I think the most important part here. In this repo, you can see those awesome apps and libraries built with Ratatui, and those are the best way to describe the TUI renaissance. Because you might ask, now that we have Ratatui, what has changed? I mean, we had this library, TUIs, what's different now? Well, first of all, we can now have shaders in the terminal. This is Tachyon FX, a shader-like effects library to enhance the visual appeal of terminal applications. It offers color transformations, animations, complex effect combinations that you now see on the screen. And yeah, it's pretty much possible now. We can also have these animations rendered in the terminal. This is Bevy Ratatouille render. If you're familiar with Rust, you might, or game development in general, you might have heard of Bevy game engine. And this library simply combines the power of Bevy game engine and Ratatouille. Also, we can have stuff like this in the terminal. It's a terminal aquarium, which lets you watch some fishes. This also uses Bevy Ratatouille render, along with Ratatouille image crate, which allows you to render images in the terminal. Hold on, did I say images in terminal? Yes, you can actually have images in the terminal. If your terminal supports 24-bit color and has reasonably efficient rendering, you can just have render images there. And I tried this with some modern terminals, Alacrity, Vesterm, and so on. So it all works. Next, we have this website. Well, now we are on to web. eGUI is a Rust library for creating both web and native GUIs. And with this eGUI Ratatui project, you can use Ratatui backend as an eGUI widget, which can be then deployed on web with WebAssembly or shipped natively with some other libraries. So basically, you can just create a TUI app, use this library, and you can just have WebAssembly that does this. And you basically, you can run this demo on both web and the terminal. So we've seen shaders, animations, images that we are now rendering on web. What's left here, right? What can we do? Well, we can do AI too. This is one of my favorite projects, actually. This is a neural network learning to play Snake in the terminal. You can see it there. It's pretty efficient. I mean, there's not much to say. We can just watch this till the morning, probably. Take a quick break. So, yeah. Moving on. Games. Yeah. Let's have some fun. This project, Tage, or Tage, is a turn-based empire warfare in the terminal. I haven't played it. It looks very cool, but I should probably check it out sometime. Well, of course, we cannot skip the system tools when we talk about TUIs. Here is Seri, a rich Git commit graph in your terminal. So if you find Git log output difficult to read, this is for you. And you can actually see the commit graph on the left. And I guess this is rendered as an image, but I'm not really sure. So it's pretty useful. And this is the Git history of Ratatui project. Apart from these individual projects, there are actually individuals that dedicated themselves to TUIs all the way. I want you to meet Pytop's real name is Butter, I guess. His awesome TUI tools are Impala and BlueTui. Impala is a TUI for managing Wi-Fi on Linux, and BlueTui is managing Bluetooth on Linux. I use this daily, actually, for connecting to my headset. And he's also working on new TUI tools that will further enhance your terminal experience. I might give you a little sneak peek here. He's just working on this thing. Okay. And meet Kleiba, Lucas Frenek. He built NetScanner, which is a terminal network scanner. He also made a presentation about Ratatouille at Rust Prague meetup. And the interesting thing is, he built his own TUI tool for the presentation, and it's called TUI Slides. And you can see it on this screenshot here that he's using that to render images or like have these slides and so on, which is, I think, pretty impressive. I used Google Slides for this presentation, and I should be ashamed. Speaking of alternatives, let's take a look at some. Goodbye, Postman. We now have ATAC. Arguably, a terminal API client is the acronym. It's a simple API client. It's very Postman-like in your terminal. And it supports every feature of Postman, mostly, and you can import your collections from it. So you can just check it out and just switch to it. Just basically, it's pretty great. And just today, the author created a new release, and he says that, please use it a lot. It cost me 40 hours of my life. So go check it out. Goodbye, Notion. We have Ricola now. It's a terminal markdown node manager, and it's more lightweight. No GUI, no web interface, no bloat, no Electron. So it makes it even faster to take notes in markdown format, and so on. Goodbye, YouTube Music. I mean, you know the drill by now, so yeah. I see Ratatouille in the front line when it comes to terminal renaissance, and this meme summarizes it very well. It basically says that even if the year is 2034, we are doing stuff in the terminal. Hey, future me. So, are we hungry? This is just before the break. Well, this is Neapolitan pizza, if you didn't see it before. And you might be wondering, what the hell is this doing in my slides? Well, I have a point. Terminal UIs are like Neapolitan pizza because you cannot hide behind a dozen toppings. So the ones that you end up using are much better quality and well thought out. Okay, and with that, on to the main man. It's time to talk about Ratatui and check out some Rust code. Here we have the features of Ratatui. To go over them one by one, it's a lightweight, immediate mode rendering library, supports many, not many, but some backends. It has custom event handling. It includes many built-in widgets that helps you build what you want in the terminal, basically. It has a simple dynamic layout system using constraints. And most importantly, it's written in Rust. It's pretty fast. And compared to most GUI libraries that use retain mode rendering, Ratatui follows the immediate mode approach, which means that UI is redrawn for every frame, and this offers flexibility and simplicity. And you can see that here, you'll have this loop, render loop, and in the render loop you will have this drove call, which takes a closure, and in that you can decide to render something or not. And it's just easy as that. I mean, you want to hide something, you just don't render it. So that's pretty much the immediate mode rendering approach. And the main disadvantage might be here is that you are responsible for both the event loop and the render loop. And in some cases, this can cause issues if the rendering thread is blocked or delayed. So you should be careful to handle these two loops in your application. Ratatui uses some backends to interface with the terminal emulator, and we support multiple backends here. And there's this flowchart that might help you choosing some backend, but most of the functionalities are the same. These backends, they are used to draw style text to the screen, manipulate the cursor, or interrogate some properties of the terminal, such as the console or window size. We also have this test backend, which can be used for unit tests. So yeah, and when one of the most important things that a backend is doing is that you enabling the raw mode and alternate screen. And just to mention them briefly, raw mode means that turning off the I/O and just giving you the full control of the events because you want to have the custom key bindings and so on, right? And alternate screen is meaning that you will go to a new screen and you will use that new buffer for your application because you don't want to stay in the same terminal. So those are two things that the backends are doing. And if you look at the comments on line 11 and 17, those are actually just NC escape codes. I mean, if you go into the Rust code and check out what they are doing, they're just printing out these codes to the console and the magic happens. So yeah. Moving on to event handling, there are many ways to handle events in Ratatui. The one that we usually suggest is, for simple applications, you can use this centralized event handling, which you will have this loop, and you will basically poll for new events, and you will handle them with some conditions, and this will be enough for very simple applications. But if you want something more complex, you can use centralized catching with message passing, which is on the second screenshot. In this screenshot, you're seeing that we are also polling some events, but we are sending them to somewhere for handling on line 17, and we use some Tokyo calls there and cross term to handle the polling. There's another one which is called distributed event loops or segmented applications. In that approach, you basically delegate a terminal control and event handling to sub-modules in your project. You avoid the need for a centralized event loop. But this might potentially lead to some duplicated code, so you should be careful. But in a nutshell, the events are handled like this. If you have a async Rust application, the second one might be better for you because it's running async and it has some Tokyo and cancellation features too. Sometimes we want to run something else in the terminal and come back to the TUI. So we usually have this cancellation tokens and like some kind of a break mechanism in the event handling to do those things. Some examples are you might want to launch Vim and come back to the TUI and do some stuff. So those can be used simply. Widgets are the building blocks of a TUI, and we use them to create, manage the layout and style of the interface. We provide a wide variety of built-in widgets. There's a list, but this is not the complete list. We have more than that, and I listed chart and table here. And constructing these are very simple. You just have the struct, and you give them some properties, and they will be rendered like this. This is not the exact representation, but just to show you how it looks like. And chart is also simple. You just have these data set that is rendered something like this in the terminal. Some other widgets are canvas and line gauge. Canvas can be used to draw anything in some area. You can see there's this beautiful painting there, or you can do other things too. And the line gauge might be used for progress bars or other things. So yeah, you can check out the documentation or the website for seeing how they look like, because we have, like, as I said, a lot of widgets. Here's a demo that showcases those widgets, and you can see that we have tab widget on the top. You can toggle those and have different interfaces there. We have this map looking thingy, and now we are on another screen doing some downloading. We have calendar and so on. So those are all possible with Ratatui, and most of these are very improved after we forked TUI-RS, and we added like calendar after that, basically, or many other widgets. So we are trying to provide as much as as many as UI elements. So yeah, and you can also create your own widgets if you want. All you need to do is implement a trait or an interface on your type. So you can implement widget trait on your type. This one is, there's the struct, and it has a name, and you implement the widget trait on that. It gives you some functions and some area and buffer, and you can run you can use some methods to render something. Or you can use stateful widget trait, which gives you actually a state which you can change. So that's the difference between them. The first one do not consumes the widget by reference, and the second one is a state that you can manage and update during rendering. You can definitely check out the documentation for more. Layouts, they dictate the structure of the interface. So you can use layouts to divide the area into two, like using these constraints. In this example, I use percentage constraints. I divided some layout into two, and then I rendered two different blocks into those two different layouts. And there are other constraints too. For example, we have something called length, which can be used for a fixed length, or max for max width, and so on. You can mix and match those, as in this example, to create dynamic and adjustable interfaces. There are some POCs for trying to use something similar to CSS using flexbox or grids, but we're still considering those approaches. So yeah, right now this is how you can use layout and constraints to create dynamic interfaces. Here's a minimal example, Rust code for a Ratatui application. You can just skip the imports. This is how it looks like. Basically, you initialize the terminal, you create a render loop, you draw your widgets, handle events, and basically clean up. And right now, we are actually working on a PR which will very much simplify this. You won't need these first 3 lines where you enable something in the terminal and so on. You'll just call probably Ratatui init or terminal init, and then when you want to clean up, you will call restore. So we're just working on that, and this will be way easier in the future. So right now this is the way, but just note that this will change, and will be easier. We don't offer an out-of-the-box guide for organizing your project, and it's your responsibility to structure it and change things, but we have some templates that you can actually use for getting started. We have simple async and component templates. You can, if you have Rust installed, you will have cargo installed, and you can install cargo generate and call this line and cargo generate, and you'll have an initialized project structure for a Ratatui application, and it will be just easier to getting started. And if you want more resources, we have examples, guides, and concepts on our website. And if you have like questions or want to discuss anything, you can join our forum or Discord or Matrix and so on. So we really appreciate feedback. If you try out Ratatui, just let us know what you think. And I want to finish off with a quote from Ratatouille, the movie actually. It basically says that the only thing predictable about life it's unpredictability, and I'd like to comment on that and say that the possibilities are endless and often surprising using TUIs, because we didn't really ask for any of the projects that you saw. Some people just came up with those. I mean, we were not really planning to have like shader rendering or like having Ratatouille on web. So the future of terminal interfaces could bring some unexpected innovations and advancements, and I look forward to that. Thank you, everyone. That was my talk. And those are my slides if you want to download them. Any questions?
If there are any questions, please raise your hand, and if I can get to you with the mic, we'll do that. Otherwise, he'll repeat them, I guess.
Can you quickly go back to the minimal example?
It's not very minimal.
Have you considered to provide a custom derive for this, similar to how Tokyo does it, where you say Ratatouille in it, and then it would get rid of the initial couple lines that you mentioned from 14 to 17?
Yes, there are actually many considerations regarding how to simplify this, and I have many ideas about that. But a drive macro was not really one of them. But we should definitely do that probably, or at least try to have a POC of that. But then the question becomes, how do you define the layout? Because I think the bigger part that we need to solve is having less boilerplate, but also having an easier way of defining the layout. So maybe it can read from a file, or there might be some other way of just having a simple way of having this interface. So that would be better. But yeah, definitely a good idea.
The way how Tokyo does it, by the way, is they allow you the flexibility to build your own runtime if you want to. So they offer the derive, but it's not mandatory to use Tokyo. So technically, you could offer some sort of builder here for terminal, for Ratatouille itself. But for the majority of people, probably a derive might be enough.
Yeah.
Thanks.
Hi, thanks for the talk. Very interesting, strong meme game. I have my terminal on my computer running in a window. How would the framework handle if I resize the window?
Okay, it's a good question. So when I showed you layout actually handles all of that. So you don't need to handle any resize or anything. I will go back to that. So when you say 50%, it will just take the 50% of the window, and when you resize it, actually it takes. Internally it receives some calls from crossterm, and if you redraw in a loop, it will just use this percentage and just resize it. So it's basically how it works. And if you use length here, it won't be resized, because you're basically saying that it will be the fixed size, 10 characters in the terminal. So we usually recommend using percentage or max or min, maybe field 2, to have dynamic layout where when you resize the terminal, it is fit to the area. So that's how it works.
Yeah, thanks for the talk. Great meme usage. Very interesting tool. I got 2 questions. The first one is, do you also support mouse navigation and button event handling, stuff like that? Okay, that's already enough, thank you. The other one is, I'm a Python developer, and there is a library called Textual that does some similar things. But I really like your project, and I wonder if it would be possible to also use other programming languages in the backend functionalities like Python, JavaScript, Bash for some backend stuff inside the applications.
So the mouse is fully supported, and you can receive mouse events, and you can actually scroll with the mouse. There's one mouse scroll down and scroll up event, so it's supported. You can use the click, mouse click functionality as well. It's a bit difficult at the moment, but we are planning to simplify that. And the second question is, we currently do not support any other languages. Some people ask if they can have C interoperability with Ratatui or some Python stuff, but currently it's only Rust, and that's not on our roadmap, I would say. So sadly, no.
I have one question. How is your support for real TUIs? As I assume you would need a kind of...
Can you repeat it? I didn't get it. Platform support, do you mean?
Yeah, no, not the platform support. Would I be able to run Ratatui into a real TUI?
Oh, okay. Probably you can if you write your own backend, because backend these cross-term, or maybe I'm not sure. I need to look into that. Well, if cross-term or the other backends do not support it, you can simply implement backend trait. There's a trait called backend, and use that implementation to run on anything, basically. So let's say you have this like a TTY or some device that you want to use Ratatouille on. You simply implement that trait, and it has some functions such as render and so on, and you can just use Ratatouille there. So it should be possible. Yeah.
No further questions? In that case, thank you for your presentation. And if you have any questions later, you can probably find him around.
Yep. Thank you.